Okay, slide number 21 is first mover advantage, the Stackelberg model. Stackelberg model is oligopoly model in which one firm sets its output before other firms do. Suppose firm 1 sets its output. Firm 1 is leader. So suppose firm 1 sets its output first, and then firm 2 follow, for example, right? After observing firm 1's output, makes its output decision. So firm 2's behavior is perfectly same to the earlier case of kernel model. In setting output, firm 1 must therefore consider how firm 2 will react. In other words, firm 1's profit maximization, right? Consider firm 2's reaction curve in deciding a profit maximizing quantity. Okay? So, same example, same to this one, right? So, we know that we're moving there. We already derived firm 2's reaction curve is this one, 15 minus half Q1 in kernel model, isn't it? Right? And leader, firm 1, that is firm 2, follower, so PA, perfectly same to kernel model. But firm 1 leaders consider this reaction curve in profit maximization decision. Okay, now think about firm 1's production. Profit of firm 1 is whatever. Price equal to 30 minus Q. So 30 minus Q1 minus Q2, isn't it? Right? And Q1. Expanding this, we know that 30 Q1 and no marginal cost, constant at 0. Okay, so total cost equal to 0. So profit is equal to total revenue, right? 30 Q1 minus Q1 scale minus Q2 Q1, same to earlier one. Right? And so this one, we know that consider firm's reaction curve in profit maximizing some process, right? So this Q2, this Q2, right, is replaced by firm 2's reaction curve. Okay, then what happens? 30 Q1 minus Q1 square minus Q1 and Q2 is equal to 15 minus half Q1. Right? That is profit function of firm 1. Then 30 Q1 minus Q1 square. This one is 15 Q1 plus half Q1 square. Right? Then 30 Q1 minus 15 Q1. So 15 Q1 minus half Q1 star. Half Q1 star minus Q1 star plus half Q1 star. So minus Q1 star. That is profit. Right? So first derivative of profit function with respect to Q1 is equal to 15 minus Q1. Right? Should be equal to 0. Then Q1 star is 15. Right? And Q2 star is this one. Right? Q2 star is 15 minus half 15. So 15 over 2 or 7.5. Right? 7.5. Then this one inserted in price. Then price is equal to 30 minus 15 minus 7.5. Then what happened? This one, only 15 left. 15 minus 7.5. So 7.5. Okay? Also, you can calculate a profit for leader. Right? Pi 1 star is equal to, price is equal to 7.5 multiplied by 15. Right? And total cost equal to 0. So that is 120, I forgot, 112.5, right? And pi 2 star is equal to, price is 15 over 2, and quantity is 15 over 2. So half of this one, right? So 66.25. Can you understand? That is Stackelberg outcome. Stackelberg outcome, right? Well, I'd like to check. Solution is like this. That is explained, slide number. I think this is wrong. 56. Right? Here, let's look at slide number 21. Right? So form 2's reaction curve is Q2 is 15 minus half Q1. Form 1's revenue is equal to PQ1. That is 30Q1 minus Q1 square minus Q2Q1. And form 2's reaction curve Q2 is inserted here. Then we get total revenue over profit, same, because marginal cost is equal to 0. That is 15Q1 minus half Q1 square. So marginal revenue is equal to 50 minus Q1. Set marginal revenue is equal to marginal cost, Q1 star 15, right? Stackelberg outcome. Stackelberg outcome, right? Q1 star is 15, Q2 star is 7.5, price is equal to, I forgot, what is? Price equal to, same, 7.5, and form 1's profit is equal to 112.5. Form 2's profit is equal to 56.25. Okay, that is Stackelberg outcome. When this is the situation, we solve corner outcome, corner solution, collective outcome, comparative outcome, and finally we solve Stackelberg model, right? And now we go section 3, price competition. Until now we studied quantitative competition model, right? Quantitative competition model. But sometimes oligopoly market compete doing some price competition with each other. Right? That is Bertrand model, explored in slide number 12 too. Price competition with homogeneous product. Price competition with homogeneous product. That is Bertrand model. Bertrand model, oligopoly model in which firms produce a homogeneous good, each firm treats the price of its competitors as fixed. Corner model, each firm treats the output of its competitors as fixed, right? But here in Bertrand model, each firm treats the price of its competitors as fixed. And all firms decide simultaneously what price to charge. Let's return to duopoly example of this kind of case. Only one difference is here. Right? Price is 30 minus Q, and marginal cost 1 and marginal cost 2 equal to 3 here. Yes, $3. Right? It is $3. In earlier example, this one is equal to 0. Right? But now 3, then we can solve everything. For example, corner model, how can you calculate corner model? Revenue 1 is equal to 30 minus Q1, Q2, and Q1, right? Then that is equal to 30Q1 minus Q1 square minus Q1 Q2, right? So marginal revenue is equal to 30 minus 2Q1 minus Q2. That is equal to marginal cost. Marginal cost is 3 instead of 2. Okay, so marginal revenue is equal to 3, marginal cost. Then rewriting this, 2Q1 is equal to 30 minus 3, so 27 minus Q2. So Q1 is equal to 27 over 2 minus half Q2. Okay? So that is the reaction curve for form 1. So form 2's reaction curve is also shaped like this. Following same process, 27 over 2 minus half Q1. Okay? So from these two reaction curve, we can calculate Q1 star and Q2 star, solution of two simultaneous equation, right? So Q2 inserted here, this one inserted here, then Q1 is equal to 27 over 2 minus half Q2 is equal to 27 over 2 minus half Q1. Okay? So both sides multiplied by 4, then 4Q1 is equal to what happened? 2 multiplied by 27, right? And minus and 4, then only 27 left, right? And this one is also Q1 left. Okay? So 3Q1 is equal to this one moving here, 4Q1 minus Q1 is 3Q1, and this one minus this one is just 27. So Q1 star is equal to 9. Right? In this case, Q1 star, Q2 star is equal to 9. Right? When this is the case. Right? Q1 star is equal to Q2 star equal to 3. Then price is equal to 30 minus 9 minus 9. 30 minus 9 minus 9. So price should be equal to 12. Right? And profit form 1 and form 2 is equal to price 12 multiplied by Q1 and Q2 9 minus so now think about marginal cost is constant as 3. Right? So average cost is also marginal cost constant, then average cost is also 3. Right? Then profit is equal to price minus average cost multiplied by Q. That is 9, isn't it? Right? And here price is equal to 12. Average cost is 3. Right? Then that is equal to 81. Okay? So that is collusive outcome. I'm sorry, no collusive outcome. That is what is this? Kernel outcome. Kernel outcome. Kernel solution is this one. Right? Kernel solution is this. And also kernel solution is this. And Bertrand model is, and Bertrand model, Bertrand solution is, so price competition. So price should be equal to marginal cost simply talking, right? Price is equal to marginal cost, right? So price is equal to marginal cost of form 1 and form 2, that is equal to 3, right? Price is 3. Then Q star, right? Price is 3. 3 is equal to 30 minus Q. Then Q star is equal to 27, right? Q star is 27. Then Q1 star and Q2 star is equal to 27 over 2, right? And profit should be equal to 0 because price is equal to marginal cost, right? Price is equal to marginal cost. That means profit is price minus average cost, Q, isn't it? Right? Price is 3. Marginal cost is constant at 3. So average cost is also 3. So profit is equal to 0. That is Bertrand's solution. Okay? When this is the case. Okay, now we go next slide. Slide number 23, price competition with homogeneous products. In other words, what Bertrand was. Now suppose that these two duopolies compete by simultaneously by choosing a price instead of quantity. Nash equilibrium in Bertrand model result in both firms. Nash equilibrium Bertrand model result in both firms setting price equal to marginal cost. Right? That is P1 is equal to P2 is equal to marginal cost 1 is equal to marginal cost 2 is $3. Then industry output is 27 units, of which each firm produces 13.5 units and both firms earn 0 profit. In the corner model, because each firm produces only 9 units, the market price is $12. I already calculated corner model, right? And the market price is $3. In corner model, each firm made a profit. In the Bertrand model, the firm's price and marginal cost and make no profit. Okay? Then we go 24. Price competition with differentiated product. Right? Price competition with differentiated product. Right? So now I'd like to use this. Erase this one. Here, slide number 24, price competition with differentiated products. Suppose each of two duopolies has a fixed cost. Fixed cost is $20. Fixed cost is $20, but 0 variable cost. Variable cost is equal to 0, right? Then marginal cost is also equal to 0, isn't it? This one means marginal cost is also equal to 0. No variable cost. And that they face the same demand curve. Firm one's demand curve is Q1 is equal to 12 minus 2P1 plus P2. Right? And firm 2's demand curve is 12 minus 2P2 plus P1. Right? That is example of price competition. Price competition with differentiated products. Okay? Then that is like this. Then next slide, choosing price, right? Now think about, in this case, firm one's profit. Firm one's profit is equal to P1, Q1, right? So Q1 is this one, 12 minus 2P1 plus P2 multiplied by P1, right? Then that is equal to 12P1 minus 2P1 square plus P2 P1, right? Then profit is this one minus fixed cost $20, right? So minus $20. That is fixed cost, right? So profit is this one minus 20 or this one, right? Then profit maximization condition is first derivative of profit with respect to P1 is equal to 0. So in simply talking, P1 should be equal to 0, isn't it? We calculate this one from here. This one is just 12 left. This one minus 4 P1. This one just P2 left. And this one disappear. This one should be equal to 0, isn't it? Right? From here we can construct reaction curve for P. From P1 is equal to 3 plus or false P2. Right? We can derive this kind of relations. Right? So then P2. So if we can do same thing in form 2. Profit of form 2 is P2 Q2. P2 multiplied by Q2 and solve. Then reaction curve form 2 is equal to 3 over 1 4 P1. Right? So simultaneous solving these two equations, we can find P1 star and P2 star, isn't it? Right? So this P2 is inserted here. Then P1 is equal to 3 plus or false. Instead of this P2, we can rewrite 3 inserted 3 over 4 P1. Right? For example, both sides multiplied by 16, then 16 P1 is equal to 3 multiplied by 16 and 12. Right? 16, 4 left, 12, and P1 left. Okay? Then 15 P1 is equal to, this one is 48 minus 12, so that is 16, 60, right? So P1 star is 4. Then P2 star, this is a 4. Then only one left, 3 plus 1. P2 star is also 4. So P1 star, P2 star is equal to 4. Okay? Then we can calculate Q1 star and Q2 star, right? Q1 star is equal to Q2 star. For example, Q1 star is P1 is 4, P2 is 4, right? Minus P1, 4, 12 minus 4, so 8 left, right? Q1 star and Q2 star is equal to 4, 8. Then we can calculate it profit. Profit, pi 1 star, pi 2 star. So pi 1 star is equal to price multiplied by Q1 minus fixed cost, right? Then what happened? 12 left. That is 12, right? That is 12. So write this. Am I correct? Okay. 12. That is fully explored in slide number 25 and slide number 5. Okay? Now we go next section. Nash equilibrium in price in graphs. Right? So this one, we draw in this graph. That is P1. That is P2. Then from here, performance reaction curve. Performance reaction curve. I erased already. What is performance reaction curve? I forgot. Performance reaction curve is P1 is equal to 3 plus or false P2. Right? That is performance reaction curve. Graphically, if P2 is equal to 0, P1 is 3. P1 is 3. And slope is of false. Right? So performance reaction curve shaped like this. That is P1 star under the assumption that P2. Right? Similarly, form 2's reaction curve is P2 is equal to 3 plus of force P1. So that is equal to like this. That is P2 star P1, right? So Nash equilibrium we calculated here is this one, right? That is solution of price competition with differentiated product as a Nash equilibrium. That is 4, 4, right? That is 4, 4. That is 4, 4. Okay? So we calculated this Nash equilibrium, right? Then now think about what happens if two firms behave like monopolist. In other words, what is collusive outcome, right? That is Nash equilibrium, right? And then what is collusive outcome in this case, right? If two firms behave like monopolists, Q, think about here, Q equal this one, right? Then Q1 is equal to, anyway, behave like P1 is equal to P2, isn't it? So then 12 minus price. Q equal 12 minus price, right? Q1, Q2 same. So we can get this kind of relations, isn't it? Right? Then profit of monopolist, right, should be equal to price multiplied by 12 minus P. Then that is 12P minus P square, right? And first derivative of total profit, right? Profit as a total divided by price. That is equal to 12 minus 2P, right? That is equal to, what is marginal cost? No marginal cost, right? That is equal to then equal to 0 because marginal cost is equal to 0, right? Then P star is equal to 6, okay? This one inserted here, we know Q star is equal to 6. In other words, Q1 star is equal to Q2 star is equal to 3, right? And profit of each firm, pi 1 star, pi 2 star is equal to what happen? 6 multiplied by price, 6 multiplied by, so 18. Okay? Anyway, we know that collusive outcome is P1 star is equal to P2 star is equal to 6. In this graph, 6, 6, right? That is collusive outcome in earlier example. Okay?